Hi, I'm Alex from the Zscaler Customer Success Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for the inspection of TLS encrypted web traffic, aka SSL inspection. This is a supplementary video, part 6. This focuses on specific security recommendations for your SSL policy. The first recommendation is to inspect traffic by default. SSL inspection is mandatory for most security engines available within ZIA. If there's no default inspect policy, traffic can very easily end up not going through these engines, leaving your devices and users in a fail-open state. Default policy should instead be inspect to build a fail-close model and secure your traffic by default. Note that implementing this can have an impact on some applications and websites, so it is recommended to test this change and introduce it gradually to avoid production outages. The next three recommendations are to do with Microsoft 365 services. The first one of these is to inspect OneDrive and SharePoint. This can be done by creating custom rules to inspect the OneDrive and SharePoint cloud applications placed above the Office 365 one-click rule in the policy list. OneDrive and SharePoint can be used by anyone, including malicious actors, to host data. Given their ease of use, the general bypass of these destinations from SSL inspection is imprudent and increases your attack surface and risk. Failing to inspect these destinations can also mean that corporate resources are bypassed from inspection, malware protection, and data protection policy. Similarly, it's recommended to inspect Microsoft Outlook by creating custom rules to inspect the Outlook Office 365 and Outlook Personal Cloud applications. Again, these must be above the Office 365 one-click rule. Doing so allows applying DLP and security policies to Outlook application and Outlook web traffic. Note that only the modern Outlook application and Outlook web are supported, as these do not have SSL pinning. Older versions will have SSL pinning and cannot be inspected. The final recommendation for Microsoft 365 traffic is to inspect Microsoft login services. SSL inspection is required to apply tenant restrictions for these SaaS applications, since traffic has to be inspected to insert the required headers into the requests. Doing this allows you to leverage the tenant profiles feature to identify cloud instances owned and controlled by your business, so that security and DLP policies can distinguish between trusted and third-party destinations. Next, a common mistake when creating exemption rules inside your SSL policy is to configure them to bypass other policies. Creating an exemption rule that is set to bypass other policies will bypass all matching traffic from all web security engines, i.e. URL filtering and cloud app control. It is heavily recommended to set these policies to evaluate other policies to ensure that URL filtering and cloud app control policies are enforced for matching traffic, even when this traffic is exempted from SSL inspection. Note that this only applies to custom SSL inspection policies that you've created yourself. System policies, such as the Zscaler recommended exemptions policy or the various one-click policies, should not be changed to evaluate other policies, as this may cause issues. Next, it's recommended that you use SSL policy to block traffic that does not conform to modern security standards. TLS 1.0 and 1.1 are officially deprecated due to security flaws. It's therefore recommended to set a TLS version of 1.2 or above as the minimum TLS version for both client and server. Similarly, untrusted certificates, which are not verified by a central authority, should not be considered safe in most cases and should be blocked. Finally, enabling the OCSP revocation check will ensure that certificates are validated per request instead of relying on a periodic refresh of the CRL. This eliminates the time gap between when a certificate is revoked and the CRL is updated. Next, it's recommended that you create sublocations for unmanaged devices. Unmanaged devices, like IoT and OT devices, guest devices, and so on, cannot install a custom certificate in most cases. This means that SSL inspection is not possible for these devices, and traffic from these devices must be exempted from inspection. Rather than exempting destinations for these devices, it's recommended that you group these devices together using sublocations where possible, so you can create source-based exemption policy. This will ensure that only designated device groups are exempted from SSL inspection, rather than risking misconfigurations exempting traffic from authenticated users. As a corollary to this, Zscaler recommends assigning location types to locations and sublocations. Location types allow policies to be applied to locations in bulk based on type, instead of selecting specific locations individually per policy. Designating a location to a specific type also helps identify the purpose of the location, reducing your operational effort. This makes it easier to build policy that leverages location types. For locations with mixed user and non-user traffic, it's recommended that you use the match criterion device group no client connector in your location-based source exemptions. Locations in the server, guest, Wi-Fi, or IoT traffic groups typically have location-based policies exempting them from SSL inspection. If corporate users connect from these locations, their traffic will likely be exempted because of this policy. By adding the match criterion device group no client connector to these policies, you can limit them to only devices that do not have client connector. This ensures that authenticated users connecting from these locations still have their encrypted traffic inspected, and security policies are applied to this traffic. Next, Zscaler recommends using FQDNs rather than IP addresses in your SSL policy. IP addresses typically represent backend entities such as servers and can be subject to change without notice. Conversely, users generally reach applications via user-friendly FQDN, which remains static since applications are directly associated with them. Building policy based on FQDNs removes the risk that backend changes will impact SSL inspection policy and makes managing policy easier since FQDNs are human-readable by IT administrators. Finally, two recommendations specific to exemptions. The first of these is to avoid using wildcard entries and instead rely on specific destination FQDNs. Wildcard entries will match every FQDN that falls under the specified domain. This can be convenient for administrators, but this significantly increases risk by turning policy into something closer to a fail-open model. Avoiding wildcard entries in these exemption policies ensures that you retain full control of which destinations are not inspected and thus not secured. One thing that's worth noting is that wildcard entries in Zscaler do not support the star symbol. Instead, wildcard entries use a leading dot. Finally, as a corollary from the previous recommendation, and to draw specific attention to this issue, it is extremely important that you do not exempt .blob.core.windows.net or .amazonaws.com from SSL inspection. These wildcards represent Azure Blob Storage and Amazon S3 buckets. Since these are public cloud platforms where anyone can rent storage, most FQDNs from these domains must be considered a potential threat. Note that Microsoft often recommends bypassing .windows.net from inspection for other applications or services, and that if done, this will also bypass all Azure Blob Storage. You are free to exempt specific known safe AWS or Azure destinations if required. The recommendation is simply not to exempt the entire domain as a wildcard, as this introduces significant risk by exempting all traffic to these extremely widely used destinations. That's it for this video. Thank you for watching.